Welcome to the CILOG 2023. We're going to present the work from created by Zinedine Escandon, Dr. Roberto Contreras, and Dr. Alberto Ochoa. The title of this research is Solving the Humanitarian Logistics Associated with Medicines in Medical Dispensaries in a Smart City. What is the purpose of this research? And this is the introduction about our work. And we have to take in consideration that there is the continuous improvement in and demands in medicines. People is requesting specialized medicine, and there's is a challenge for the logistics companies to create the optimal networks, the optimized routes in order to find and arrive in time with the right medicine. So to begin with, they must be able to deliver the right level of satisfaction to their customers or users. So therefore, the objective of this research is to expose what are the results if we use an implementation using a software tool that is user friendly and is relies, better saying, with the graph theory. And using these components, we can analyze and find the ideal and optimal solution to humanitarian logistics. Uh, First of all, we have to recall a little bit, remember the graph theory, and that's very useful for vehicle routes. Um, Graph theory has become a very useful tool, is the graphs, and we can put the nodes, the different nodes in the figure. We can use it with letter V, and also we have the distances that separate it to each point or the available routes to be able to transit. So in this problem, we need to find what are the optimal uh, arcs in order to go from point A to point B. And also we have to take in consideration this intelligent application that we are proposing. And we rely there is a, we're using the Humanitarian Logistics Python, and that was provided by a nationwide transportation company that is located in Mexico. And why we use this kind of tool? Because there is a lot of complexity of analyzing all the national operations in, within this company. And when we arrive with them and tell them we can use or we want to use a regional case, they accepted to provide it. So the case that we're going to use here and we're going to show is a small regional case that is composed of a fleet of 17 vehicles, all of them with the same technical specifications and similar load capacities. So the variables that we're going to see in a moment, um, they're not going to be with different trucks or different vehicles. So in this situation, in this case, we have to identify first the delivery points, and we have 7 points in within the city. And they're in table 2, and we can read them the different names of the locations. So even if we see like example in letter C, kilometer 2027, that's a specific point that is known in the region, like neighborhood or a specific point. The same happens with Mexico 68 is a specific neighborhood that is well known. And we take also the different the distances from each of those points. So for instance, if I want to go from Chavena to Las Torres, that's going to be resulting on 344 units of distance. Uh, the same happens if I want to go from Los Aztecas, that is point G, and I want to go to Point Parajes del Sur, that is very far. We find that it's 1246 points. So So that's we have to create that matrix in order to identify the graph and also the distance between each of the points. Uh, Also, we can do the different matrix of distances, and this is a zoom in of the map of the city. And here we can find all the different points in within a region. That's very useful in the tool that we are using. Uh, and the second thing that we need to um, create or define is the operational variables. And here is more important. Now we have the distance, we have the number of trucks, and we said or that they are from the same kind, the same capacity. So the variables that we have is the demand and cargo supply. That's the first one, and that's expressed in kilograms per month. Also, the fixed and variable cost, that is $7 per month. The capacity of the vehicles, that is can be loaded in kilograms per month. The maximum distance that they are expressed in miles per month that a truck can go. And there is some fixed cost for vehicles, and there is a 1200, 2500 per 7 months for each vehicle. And there is also a variable cost that each vehicle is going to cost 2750 per kilometers. And also the capacity that we need to transport is stated in kilograms per month. And this is important. The capacity and the capacity of the vehicles should be in the same units, and also the demand and the cargo supply that we can have, they should be in the same units. So when we run the implementation, we have here a nice view of the city with the different regions, the different points, and some dispersions about what calculations for for the optimal routes in this exercise. And at the end, with this tool, we can find what is the optimal route that we need to follow in order to do the supply and the demand. So this is a very interesting, um, a very promising research about how to use the tools that can be available, open source, um, that can help the different um, companies that can provide and supply medicines, and sometimes not to a pharmacy, maybe far away in another areas or different cities or regions where there is no a network of or pharmacies or drugstores. So in conclusion, the solutions that we have is the best uh, troubles that we have is if we go from Las Torres, Puerto de Palos, and then go to Las Torres, Mexico 68, and then find the third travel, the total distance in point of our proposal index is 2477. Um, that's going to be cost in pesos per year and 97,500. But if we take the second route, that is going, instead of doing that, and we can do all the route, we can see the second option is could be better. Las Aztecas, Puerto de Palos, and then the kilometers, then go back to Las Aztecas, from Las Aztecas, Parajes del Sur, La Chaveña, and that's going to provide a better um, distance, and therefore is going to be cheaper, the trade, from saving around 10,000. So that's a solution that is very promising, that we can or the companies can do more or reach out more people with less cost. So in conclusions, the conclusion that we have is, well, uh, in the region, most local professionals do not have sufficient logistics capabilities. So the use of free downloadable software to solve those complex problems is a really good first approach, and that put them in an asymmetric competitiveness. Saying that because it's asymmetric, because they can mimic or they can do similar tasks and similar optimizations that the big companies can do, but they can do it with few resources. So in that in that moment of doing that, the companies with low resources or without the sufficient logistics capabilities, they can now do the right a similar thing with an optimized resources. And using that approach optimizes cost, and in consequence is going to provide a really good or a competitive advantage to that company. So they are now they can compete against the large ones, and they can provide that service or attend the areas where the large companies are not willing to arrive, but it's not going to cost a lot for them. And also, well, the Dijkstra's algorithm is useful, and we can say that this is a really a useful algorithm that can help and solve um, problems with several variables. Here in this part of Mexico, there is a well, that requires, there's a weather change or route that are not very easy to drive, and they can have variable cost. And that's a very common scenario in the northern states of Mexico. This also opens the door for future research, and you, we can optimize the routes using meta heuristics like estimation of distribution algorithms or cultural algorithms, and that can improve the model that we proposed. But also other applications that we can use are energy distribution or energy consumptions. So now that we are going, maybe it's not the right moment or it's not very common, but we're moving to electric cars. And the idea of the tendency, the trend is we're going to that point. So as we reach the popularity or increasing the popularity of green cars or electric vehicles, there's going to be a demand of charging stations. And using this kind of route optimization algorithms, also the software, we can establish what are the best location for the charging stations. So there is uh, a really good future for this. Logistics are going to be all the time useful, and they're going to be needed. Even if we are living in a digital world right now, the logistics are a very important part of the supply chain and the value chain that the companies can provide. If we are dealing with physical items, uh, there's no way that we can send them in a digital form. So the only resource left is we need to use logistics, and this kind of algorithms opens the door for the small companies to provide also a high quality service, and saving costs and saving resources. So thank you very much for your attention. We are open if you have any questions or you want further information, please reach out, and we'll be glad to answer and be in contact with you. Thank you very much.